So next, let's discuss about the step deviation method. Step deviation method applied for the continuous data. So we know that in continuous data, we have a something called as class interval, right? We have learned in the previous video that what are the different type of class interval, how to find the cumulative frequency and all. So here, since there is a class interval, the formula will become mean equal to A plus summation fd by n. And since there are both d over here, I will put one small prime over here, dash, just to differentiate it. Here, your d equal to x minus a by c. Now, what is this c? Its c is nothing but the class width. Okay, this is how we can define. So, this is your third formula of the, sorry, not third formula, 1, 2, 3, fourth formula of the mean. Let's take an example and try to solve this, how to do that. Before that, in continuous data, I will show you how to solve using the direct method. Then we will go for this, because continuous data we have not solved a mean. So continuous data will have a class interval and will have a frequency. So let's take class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Frequency, let's take 2, 5, 7, 3, 2. Right? If you add this, you will get the n, that is nothing but 7 plus 7, 14. Let me make this as a 3. So 3 plus 3, 14 plus 6, 20. It is becoming 20. N equal to 20. Right? So first we are going to solve this. We have to find the mean by using the direct method, and then we will move on to this, because I have not shown you how to do using the continuous data. Right? So here we have f and x. But here if you observe, there is no x. So what to do with this? For that, first we need to find out the x. X is nothing but midpoint. Midpoint of class interval. So how do we find the midpoint of the class interval? Upper limit plus lower limit divided by 2. This is how you find the midpoint. Right? So this is one more formula. If you want, you can make a note of it. Upper limit plus lower limit. So 0 plus 10 divided by 2 is nothing but 5, 15, 25, 35 and 45. Okay, so this is, we can do like that. Once we got the x, we don't have to worry about this. Now can you see, this exactly look like our discrete data. So after that, we can find x and f. F into x we can find, that is 2 5s are 10, 15 5s are 75, 25 7s are 175, 35 3s are 105, 45 3s is 90, 135. Right? And if you add this, you will get summation fd. That we will divide with the 20, that we will get the mean. Right? I will give you as a homework, try doing that, how much you are getting. Right? Okay. So this total divided by 20 will give you the mean. So let's find out only 5 plus 5 plus 5 plus 20 is 0, 2, 0, 2, 3, 4, 5. So you are getting 500 if I am not wrong. Just check with the calculation. There might be a mistake. So basically you are getting 500 by 20. You can cancel this to 25. So your mean is nothing but 25. Right? So this is how you can find using the direct method in the continuous data. The only small difference was we have to find the x, that was the midpoint. Right? Next, same problem we are going to solve using the step deviation method. We are going to solve using the step deviation method. We have the formula. We will take the same problem. I'll just erase this part, just not to have a confusion. Okay? I hope you have noted down that. In case if you have not noted down, rewind the video, go back and note it. Now, again same thing, we need to find a, to find d prime. So a, from the x, let's find out the middle value. Right? So it will become the a is the middle value. Then we have to find out the d prime. So d prime, I will be taking x minus a is nothing but 25. And what is the c? C is the width of the class. So each class you can see what is the difference. 30 minus 20 or 20 minus 10 or 10 minus 0. It is nothing but 10. So this is how you can decorate the formula. Now let's substitute. X is how much? 5 minus 25. How much are we getting? 20 by 10. So you are getting minus 2. minus 1, 0, 1, 2. You see this, you will get the exact same answer, right? Next, after once you get the D, we are going to multiply with it according to the formula. See, in statistics, it is always suggested that first you write the formula what you have to find, accordingly whatever is required you try to find out, because if you keep by hearting the table, it's going to be very difficult for you to remember, because there will be so many formula and so many methods, so many columns will be there. So it's always better remember formula, based on that you find out whatever it is. F into D prime. So 2 2s are 4, 1 5s are 5, 0, 3, 6, right? So how much are we getting? Minus 5 plus 4, 9, and oh, coincidentally here also 0. It's just a coincidence, nothing, since we are taking the random problem, it's just a coincidence, nothing serious about it. Like, it's not necessary you will get the 0 over there. You will see the answers, you will not be getting 0 when we will solve the practice problem. Right? Okay, so let's solve this. So we have a mean formula is A plus summation f d prime by, oh sorry, there is one small mistake. Here you need to multiply with C. C is nothing but a class interval into C. Right? So A is equal to how much we have assumed? 25 plus summation f d is 0, n is equal to 20 into C is 10. So this is all together. So 25 plus this will become, entire thing will become 0, because 0 divided by anything is 0, multiply with anything is 0. So finally we are getting mean answer as a 25. So basically what I'm trying to show is, any method you apply to do that, you will get the answer as the same, right? So this is about the arithmetic mean in the grouped, ungrouped, discrete, continuous, assumed mean method, step deviation method and all, right? So I hope you got a little clarification about the mean right now. We will do few more questions based on this in the practice session, but right now pause the video and note down these things, then we will move further and we will see what are the different methods we have under the arithmetic mean. Under arithmetic mean, we are going to study different methods now, two different methods right now. The first one is weighted arithmetic mean. First one will be weighted arithmetic mean. Now what is weighted arithmetic mean says that instead of frequency in the data, they will give you the weight. Like for example, earlier we used to have x and f, so now it will come as a weight. So formula remains the same, the mean equal to mean weighted. So we'll denote like this, mean suffix w summation wi xi divided by summation w, right? So this is how we'll denote the weighted arithmetic mean, right? So let's take one example. Assume that I have 5, 10, 15, 20, 25, 30, and then weight they have assigned is nothing but 2, 1, 4, 5, 5, 2, 1, like that, right? So what are we going to do? As the formula suggests, wi into xi, we are going to multiply this, w into x. So each value we will multiply and we are going to add this, right? So 5 2s are 10, 10 plus 10, 15 4s are 60, and 25s are 100, 25 2s are 50, then 31s are 30. If you add these things, you will be getting 0, 8, 10, 16, 1, 2. You are getting 260, right? Similarly, if I have to find summation wi, is nothing but adding up all this data. So 3 plus 5, 8, 8 plus 4, 12, 12 plus 1, 13, 13 plus 2, 15. So you are getting 15. So finally your answer will become 260 by 15. So if you can cancel this, 5 3s are 5 5s are 10, 5 2s are, and then 17.33. So this is how you can calculate the weighted mean. It's just like your discrete arithmetic mean. The only difference is, in place of discrete data and in place of frequency, they will be giving you the weight value, right? So pause the video to note it down, then we'll move on to the next method. Next, we will talk about the combined mean in the arithmetic mean. So next method we will talk about combined mean. Combined mean. Combined mean is nothing but they will be giving you the different means. Like for example, assume that I've taken the two classes, section A and section B. I found the attendance percentage of section A and average attendance percentage of section B of any classes. Two classes I have. Now I want to find out what is the overall attendance percentage. So I don't need to go back and do the analysis once again. Instead, what I can do is I can take the average value of the two sections and I can combine that and I can find the overall combination mean value. So with that, the formula will become XC. Mean for combination will be nothing but x1 bar n1 plus x2 bar n2 and so on, depending on how many data you have. Each you have to multiply with your number of observation. Like number of observation is one class has 50 students, so n1 will become 50, another class has 60 students, n2 will become 60, sample number, divided by n1 plus n2 plus and so on. So this is the formula that you apply. Why I have put the dot here is sometimes you will have a 2 means to combine, sometimes you'll have a 3 means to combine, sometimes you'll have 5 means to. So how much ever mean you have, you just keep adding that, right? So take one example. Let's take class 1 and class 2. Okay, n value, number of students, n value is nothing but, let's take here 50 and here 55 or 55, and then mean value is they have given is nothing but, let's take 20 and this is 30, right? So this will become n1 and this will become n2, we'll assume that, and this is x1 bar and this is x2 bar, correct? After that, what are we going to do? We have to find the combined mean, that is xc bar, then n1 x1 bar plus n2 x2 bar divided by n1 plus n2, right? In that condition, let's put that. So 20 into 50 plus 55 into 30 divided by 50 plus 55, right? So you can add, subtract and multiply, and then you can find out the answer. Now in this, there will be a little variations also. Sometimes what happens, since we have, let's assume that we have a 5 value here, that n1, n2, x1 bar, x2 bar and combined mean. Out of this 5 value, any 4 they can give. They might give you this, this, this and this. They will not give this particular thing. So how do we find? Again the same thing. Make use of the same formula, substitute everything. This everything will be substituted, only this part won't be substituted. So this you can solve it, right? I will upload few questions based on this on the exercise, as well as I'll be solving the questions which is related to this in the practice set. That time you can refer that. But right now understand this, there will be little variations in this method to solve that particular thing, right? So pause the video to note it down and we will move further. We will see the next method.